Alrighty. How you doing, everybody? We're going to try to get you kicked off today with starting chapter 30, which is the Biot-Savart law. And the Biot-Savart law just basically talks about the right-hand rule for current carrying wires. And if you look at the picture that's shown on your screen right here, what they're trying to do is have you take your right hand, at least in the top image here, image A. They want you to take your right hand and point your thumb in the direction of the current, and then your right hand will curl in the direction of the magnetic field. And so that's what they're trying to show you here with the idea that, let me see if I can get this thing to mark up a little bit. So they're putting the X here because your fingers would curl into the page, and as you wrap your hand around, your fingers would come out over here. And so that's what they're trying to show you with this. So to the left of the wire, the magnetic field is directed into the page. To the right of the wire, the magnetic field is directed out. If we were directly above the wire, the magnetic field would be directed to the left. If you're directly below the wire, it'd be directed to the right. The whole magnetic field just goes in a big circle around the current carrying wire. Now that magnetic field gets stronger when you're closer to the wire and weaker when you're farther away. If they change the direction of the current, then you're looking at something here. So look, you can see they have those things flipped. Let me see if I can get rid of these guys. Two programs don't work well together, the screen capture and the kind of fake smartboard program. And then here, what they're trying to show you is, if we look at this particular picture right here, then that little X in the middle right here, is this thing still lighting up? Yeah, right there. That would be the current carrying wire, and that is directed into the page. You can still see the X there. And if you look, those magnetic fields are drawn concentrically around it, and they are closer together closer to the wire, and they get farther away from each other, farther from the wire. And as with all fields, that indicates that the magnetic field is stronger closer to the wire and weaker farther away. And then also I have drawn here, if you look, like if we go out radially, that's what this red line is supposed to do. I have field vectors drawn here, 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 to try to show you that the magnetic field is pointed in those directions, and that's the approximate field strength.